How does a CPU run programs? We have CPU chip, Snapdragons, all kinds of CPU chip for the cell phone and the laptop, Intel CPU. We go through all the CPUs, how it works. It's a crash course of CPU architecture today. Okay. First of all, as you know, there is a memory. It's usually called DRAM. The DRAM is a dynamic RAM. It can be any kind of RAM. RAM is random access memory block. And disk storage is kind of semi-random, but mostly serial. And data come from disk storage and go to the memory. But memory size is limited. Disk space is like laptop. It can be 1 terabyte. The memory can be like probably several gigabyte. So what it does is the memory behave as if it has all the data. Okay, that's why it's called virtual memory. And what it does is actually say if you have a chapter 1 to 12 for one file, it's load up only necessary chapter 3 and 4. And when CPU said I need the data from chapter 5, they immediately loaded up chapter 5, and when memory ran out, eliminated some of them not used. So this is called virtual memory management. Okay, and this is done by OS, operating system. Now memory to inside the CPU, each memory contains the instruction to execute the program. The machine code is like 64-bit, and some of bits has the instruction is like add two numbers or multiply or whatever instruction, move the data. Okay, and part of the 64-bit has an address for register. There are say 16 register for A, 16 register for B. Those are like in the programming language, like add A, C, mean to register A, and the C you add, and it's come back to register C, kind of instruction. Okay, so you select the register, and usually there is a cache between, and cache is the often used memory content is kept here, so CPU has quick access instead of finding several gigabyte of memory. Okay, so it's a hierarchy. It's a smaller size but faster as you get close to the CPU. Or we can just get the data from the memory directly to direct to memory data. Okay, any of this can be used. Depend on the CPU chip, the instruction set. You can use any of them to execute. So this is a CPU inside, so-called the core of the CPU. The data come from either register or another temporary memories, the register from the memory, and this instruction is decoded, right? And this one control which one to open, this one or this one, or this one or this one. Okay, and which one to take, this one from this one or this one. Those traffic control. This instruction decoder does traffic control. Then after it's add, multiply, whatever the operations done, go to the output register, and whatever the format necessary. There are many different format like integer, floating point. This is the decimal number. Integer is integer. So the format conversion if necessary, and go back to the register. Okay, so basically it's repeat within the CPU, core CPU, and the new data every time brought in from memory. If not in the memory, it's from disk. Okay, as needed. Now it has a simple instruction only. It's called RISC. RISC is a reduced instruction set. It does only add, multiply, whatever the hardware allow. Okay, but there is a CISC, like Intel CPU is a CISC. What that is like a divide. You have to subtract many times. The subtraction repeated many times to get the result, and that you can do it by software using RISC, or it has the built-in microcode which does it, because the result never go back to memory. Intermediate result go back to the register, those register, and go back, subtract again. It's repeat. The data circle around many times. That control is done by microcode, and this kind of CPU chip is called CISC. Okay, now there is another one called pipeline. Pipeline is like the assembly process of the car. If you make a car, takes 30 minutes to make a car, each one. So each one takes 30 minutes. But if you pipeline, then each part is added in 2 minutes, and go to the next stage, 2 minutes. But you can get new car every 2 minutes instead of every 30 minutes. Okay, so same thing happen in a computer operation. When you have thousands of multiplication to do, then you do pipeline. So every clock cycle you get the result instead of finishing one and go to the next one. So inside the CPU architecture can be pipeline, and that's what supercomputer use. Okay, but nowadays supercomputer, instead of pipeline, they use parallel CPU. Parallel CPU is if you have 1,000 of multiplication to do, then it's give to each CPU the job and let them do it instead of pipeline. Okay, so it's a parallel, and the parallel is not at the CPU core level. Some have multi-core, like Intel has 8 core, so you can do 8 parallel calculation. Okay, now I mentioned that there is a cache, and cache management is important for the CPU. Those are the aspects of the CPU architecture. Okay, so when you say how many instruction can do per second, the risk will be higher because it's got to do only simple instruction. CISC sometimes take longer time because inside microcode does complex calculation, right? And some of them has even the sine, cosine calculation. Okay, so you cannot just compare by the number of instruction per second. Okay, so they use a benchmark test. It's LIMPAC, or there is an international standard LIMPAC test, and they check the performance, how quick they can complete this test program. Okay, that's what they do for the supercomputer, and compare, see what the performance of supercomputer is. Okay, so you look at the CPU chip, you see so many pins. What are they? Well, if you do 64 bits, the database needs 64 bits. And some of them, the CPU has additional 64 bits for different bus. The bus is separated, right? So there are so many pins. Then how about those chips? What are those chips? Those chips are capacitors. Why you need capacitors? Well, CPU is power hungry, and when you provide the power, the current, okay, the current's gonna dip when it's consumed a lot, the voltage drop. So in order to make this kind of fluctuation of voltage less, you put a lot of capacitor, the temporary storage of the electricity. So when it's start dipping, capacitor provide enough current to bring it up. So those chips are usually capacitors, a lot of capacitors around the chip. And power pin is not just one. Power pin is distributed, and the ground pin is also distributed to balance out all the power supply. I'm talking about power consumption. CPU's power consumption is not constant, okay? The reason is most of CPU nowadays made by CMOS. That means there is a gate to gate, and when this is high, then this open up, but this close. When this is go low, then this close, this open up. So when you look at the voltage here and current flow, there is a switching current only when it's a transition current flow. Once it goes high or low, almost zero current. So what's happened is this kind of circuit consume current only when it's switching. So more gate switching means CPU is active doing something, more power is consumed. Okay, so when CPU is doing nothing, it's idling, then power consumption is very low because CMOS gate doesn't consume any power, almost zero power. And you have millions of that gate. Maybe some gates are switching around, so the average power consumption shows up. Okay, and most important aspect of power consumption is that mobile phone need to limit power consumption, because what's happened is battery life is limited. Battery is improved, but still the goal is to have at least a few days the mobile phone is working. That means CPU power consumption is a concern. Okay, so that's different aspect of the CPU. I hope you enjoyed this course, and please check out the videos. We have all kinds of other learning videos. Thank you for listening.